Today we're going to talk about section 1.1, which is all about equations. Before we actually solve the equations, let's take a minute to talk about what it means to be a restriction. A restriction are values of the variable that are not allowed. That means that if you got them as an answer, you wouldn't be allowed to use them. You would have to toss them out. There are two ways that we can have a restriction. The first way is if there's a variable in the denominator. The denominator can't equal 0, so any value that makes the denominator 0 is a restriction. In this case, we should be able to look and see that 5 would make this denominator 0. So 5 is going to be a restriction. The other type of restriction is a restriction for a radical, or a square root. In this case, we're not going to allow the number under the radical to be negative. So we're going to take what's under the radical and set it greater than or equal to 0. Now, we have one restriction. We know that b can't be 5. We can say b does not equal 5. But the other has to do with this radical. And you simply take whatever's under there, set it greater than or equal to 0, and solve for the variable if it isn't already solved for. So here's the answer to example 1. Before we move on, let's be sure to talk a little bit about a situation such as this. If we were going to talk about the restrictions for this problem, we simply take what's under the radical, make it greater than or equal to 0, and solve for b. So this would be the restriction for this particular problem. Next, we want to talk about the three types of equations. They are identity, contradiction, and conditional equations. Basically, if you want to classify an equation, it's easiest just to look at the answer. So if you get an answer that is all real numbers, that means that that equation is an identity. If you get an answer that is no solution, that means the equation is a contradiction. If you get any other answer, the equation must be conditional. So let's take a look at example 2. We have 3 times x plus 2 is equal to 5x plus 2. The first thing we need to do is distribute to get rid of the parentheses. That gives us 3x plus 6 equals 5x plus 2. Now we want to get the variables all to one side. I'm going to subtract 5x from both sides. And that gives me negative 2x plus 6 equals positive 2. Now I want to subtract 6 from both sides to get rid of the constant. So I have negative 2x equals negative 4. Divide by negative 2. And we get x equals positive 2. If we put positive 2 back into the original equation, it should make the two sides equal, and that way we can check our work. For the next example, we would like to find the solution to 3/2 y minus 2/3 equals 1/5 y. The first thing we want to do is clear out these fractions to make it a little easier to work with. So I am going to find the least common denominator of all three of those fractions, which in this case would be 30, and multiply both sides through by it. That gives us 45y minus 20 equals 6y. Now we're going to subtract 45y from both sides. We have negative 20 equals negative 39 times the y. And finally, we're going to divide both sides through by negative 39 to isolate y. So we know that y equals 20 over 39. Anytime you get something kind of strange like that, definitely go through and check it and make sure that you haven't made a careless error. Here, for example 4, we have two different types of equations. I think one of them is going to be an identity and the other is going to be a contradiction. Let's work on part A first and see what we get. We have 3x plus 15 is equal to 3 plus 3x. Notice that when I subtract 3x from both sides, the x's actually cancel. So all of my variables cancel, leaving me with 15 equals 3. We know that 15 can never equal 3. That's what we call a contradiction. So the solution actually is no solution, making this a contradiction. Over here, when I work on this one, I get 5 plus 5x plus 10 minus 2x is equal to 3x plus 15. Combining like terms, we get 15 plus 3x is equal to 3x plus 15. Most people realize right here that the left side and the right side are exactly the same. If you realize that, you can go ahead and stop and say that the solution is all real numbers. That means that any value you plug in for x would make the left and right side true. If you want to keep going a little further, we see that 15 equals 15. So once again, our variables cancel, but this time what's left actually is true. 15 does equal 15, and it always equals 15. And that's how we know the solution is all real numbers, making that an identity. If we look back at the previous problem that had an answer of 20 over 39, if we had chosen to classify that one, it would have been a conditional equation.